Hello and welcome back to this lecture. In the previous session we have discussed about the functions overview. In this session we are going to discuss about a very special type of function which is called as recursion function. So let's start. Okay, so in C it is possible for the functions to call themselves. Okay, that means a function is called recursive if a statement within the body of a function calls the same function, sometimes also called as circular definition. Now recursion is thus the process of defining something in the terms of itself. Okay, let's now see a simple example of recursion. Suppose we want to calculate the factorial value of an integer. As we know, the factorial of a number is the product of all the integers between 1 and that number. Okay, for example, 4 factorial is equal to 4 into 3 into 2 into 1. Okay, now this can also be expressed as 4 factorial is equal to 4 into 3 factorial, where this exclamation stands for factorial. Okay, now thus factorial of a number can be expressed in the form of itself. Okay, as we can see from this expression. So this can be programmed using recursion. However, before we try to write a recursive function for calculating factorial, let us take a look at the non-recursive function for calculating the factorial value of an integer. Okay, so this is the function. We have to work through the program carefully till we understand the logic of this program properly. Okay, recursive factorial functions can be understood only if we are thorough with this implemented logic. So let's try to understand this function. Okay, basically in the main function we have the variable int a. So we have printed the message to enter the number and just read the number and store it into variable a. Okay, and we have passed the same variable to the function defined as factorial. Now in this function of factorial, it just copies the value of the variable and it runs a loop from the numbers to 1. Okay, and within the loop it just multiplies all the integers from the number and 1. Okay, as you can see, the factorial of a number is product of all the integers between 1 and that number. In the end, the factorial is stored into f and this f value is returned. Okay, so I hope this functionality is clear. You can see the output also, like if the number is entered 3, the factorial value will be for I equal to 3, which is greater than equal to 1, f equal to f multiplied by I. So by default f is 1, so 1 into 3. Okay, next time it is reduced to 2, so 3 into 2, 6. Next time it is reduced to 1, so 6 into 1 will be 6. Okay, now let's see the recursive function. Okay, so this is the recursive function. In the first run, when the number entered through scanf is 1, let us see what action does recursion take. Okay, now suppose this number that we have entered is 1. So the value of a, that is 1, is copied into x, that means the recursive function. Now since x turns out to be 1, so this condition that if x equal to 1, it's satisfied, and hence 1, which indeed is the value of 1 factorial, is returned through the return statement. Okay, that means if x is equal to 1, we have returned the 1 because factorial of 1 is 1. Now when the number entered through scanf is 2, then x equal to 1 test failed. Okay, so we reach the statement f into x multiplied by again the recursive of x minus 1. So we multiply x by recursive of x minus 1. Now since the current value of x is 2, it is same as saying that we must calculate the value of 2 into recursion of 1. Okay, now we know that the value of recursion 1 is 1. So the expression reduces to 2 into 1, or simply 2, which is the factorial of 2. Thus the statement x multiplied by recursion of x minus 1 evaluates to 2, which is stored in the variable f and is returned to main. Okay, where it is duly printed as factorial value equal to 2. Now perhaps you can understand what would happen if the value of a is 3, 4, 5 and so on. Okay, so this is the modified form of the previous code in which we have calculated the factorial. Okay, here what we have done is we have defined the function to calculate the factorial, and within the body of this function we have called this same function inside it. Okay, so this is a type of recursion function. Now let's understand the control flow, that how the control is flowing from the same function. Okay, so assume that the number entered by the user is 3. Okay, so Now this figure shows that what exactly happens when the recursive function gets called. Okay, so let's start with 3. So from the main we have the value for this function call. So recursion integer x is equal to 3. Now it comes to the body of the function. So x is equal to 1. Okay, so this condition fails. Let's come to f equal to x multiplied by recursion of x minus 1. So from f equal to x multiplied by recursion of 3 minus 1, which is recursion of 2. So we have to see the value of this particular expression. So for that we have to again get back to this function call. So it just jumped to again the recursion function. So recursion int x. Now here x is equal to 2. Okay. Again it comes to the body of the function, and again this condition fails because x is not equal to 1. Jumps to the else function. So f equal to x multiplied by again recursion of x minus 1. Here it is 2 minus 1, which is 1. But again the function is called recursion of int x, and here x equal to 1. So if x equal to 1, it returns true. Therefore here return statement is taken from 1. Okay. So f is equal to x into 1. Okay. From here it gets the value f multiplied by x into 1, and for this function x the value will be 2. So return f. So it will be written here 2. So f will be 3 multiplied by 2. Okay. And at the end we have f having the value 6. So return f will give the value to main function, which is the final value of factorial of 3, which is 6. Okay. I hope the concept is clear. Basically we are doing the same functions call again and again depending upon this conditions. Okay. So if we are starting with any number, so it just keep on reducing till this condition is satisfied, that is x equal to 1. Okay. So when it satisfies, the recursion stops, and finally we have the output as in factorial. Okay. Similarly we have the types of function call, that is call by value and call by reference. We'll discuss with the introduction of pointers in the next session. Okay. But for now, just pay attention to recursion and stack. Now there are different ways in which data can be organized. Okay. For example, if you are to store 5 numbers, then we can store them in 5 different variables: array, a linked list, a binary tree, etc. Okay. Now all these different ways of organizing the data are known as data structures. Okay. The compiler uses one such data structure called stack for implementing normal as well as recursive functions call. Okay. Now a stack is a last in first out data structure. This means that the last item to get stored on the stack, often called push operation, is the first one to get out of it, often called as pop operation. Okay. We can compare this to the stack of towels or the stack of plates in a cafeteria. Now the last plate that goes on the stack, that means the topmost plate, will be the first one to get out of it. Okay. So basically these are the example of stack. So now let us see how the stack works in case of a above program. Okay. So let's consider this program. We have a main function in which we have value of a and b as 5 and 2, and in C we have function for add in which the 2 parameters are passed, and at the end we are returning the sum of the 2 numbers. Okay. So let's understand how this stack works in this example. As you can see from the figure, at the beginning there is empty stack. Okay. So in this program, before transferring the execution control to the function fun, the values of the parameter a and b are pushed onto the stack. Okay. So value of a and b has been pushed onto the stack. Following this, the address of the statement printf. Okay. Because right now printf cannot be performed because we don't have the values from the functions. Okay. So for now, the address of this printf has been stored on the stack. It is necessary to post this address on the stack. In function, the values of a and b that were pushed on the stack are referred as I and j. Okay. So the local variable sum gets pushed onto the stack. So basically I and j copies the value of a and b and pushed to the stack with the address, and at the end the sum is also pushed onto the stack. Okay. Now when the value of sum is returned, sum is popped up from the stack. Okay. That means when sum is calculated, it is returned to the main function. So it is removed from the stack. Next, the address of the statement where the control should be returned is popped up from the stack. That means at what address we have to go after returning the sum. Okay, that means we have to go to the main function, that means the printf. So popped up from the stack. Now using this address, the control returns to the printf function, and before execution of printf, the two integers that were earlier pushed onto the stacks are now popped off. Okay, so now a and b, which were added on the stack. So after returning the control from the function, the printf statement executed and all the data has been popped up from the stack, and at the end stack become empty once again. So if this flow is clear, now let's try to implement the recursion function that we have discussed for calculating the factorial using the code block. Okay, let's jump to the code block window, click on new empty file, save this file to function folders. Okay, rename it as recfunction.c and click on save. Add comments like demonstration of recursion function, including the standard input output.h header file. Start the main function, define a variable like int a and fact. Okay. Next thing is we have to printf, enter a number. We need to store the value scanf %d comma ampersand a. Okay, so we have stored the value. Now next thing is fact is equal to rec, that means calling the function and passing the parameter value as a. Okay, and at the end we have to printf the result as factorial value is equal to %d, and here passing the value of fact. Okay, now let's define the function, which is int rec. It takes the parameter as int x. Okay, now start the body of this function, define a variable int f, which is equal to 1, let's say. Okay, if equal to 1, then we have to return 1. Okay, but if x is not equal to 1, then we have to write f equal to x multiplied by recursion of x minus 1. So at the end we have to return the value of f. Okay, that means the factorial. Okay, so let's try to build the code. Okay, as you can see, there is no any errors. Now just click on run. Okay, so you can see the message, enter a number. Let's say I'm entering 4. So the factorial value is 24. That means 4 into 3 into 2. So 4 3 is a 12, 12 2 is a 24. Okay, so this is the factorial. Okay, let's try running again. Let's check the factorial of 10. Okay, this is the factorial value of 10, which is 3628800. That means 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 gives you this value. Okay, that's all for this session. If you find any difficulties, feel free to reach us. Okay, so see you in the next session.